Today, we're diving deep inside the semiconductor fab. We're going to tackle a massive challenge. How do you solve critical, multi-million dollar problems that are, well, completely invisible? You know, the stakes in chip manufacturing are just through the roof. We're talking about features smaller than a virus, where a single tiny group of atoms in the wrong place can completely wreck a production run. I mean, that can wipe out millions of dollars in revenue just like that. Yield loss is one of the biggest nightmares in a fab, so finding these tiny, incredibly expensive errors, it's everything.
So this brings us to the big question, right? As our chips get more and more complex, the problems they just get harder to find. It's a classic engineering paradox. The very thing that drives the industry forward is also hiding the defects that could bring it all to a grinding halt.
And this challenge, it gets even bigger with architectures like 3D NAND flash. To get more storage, we stopped building out and started building up, stacking memory cells into these massive vertical skyscrapers. Well, that created an engineer's worst nightmare. Now, the critical features and the potential defects are buried deep inside these structures, creating what the industry calls the measurement gap. So, what is the measurement gap? Well, basically, it's when your inspection tools just can't see the things that matter the most anymore. Think about it like this. It's like trying to inspect the foundation of a 100-story building, but you're only allowed to look at it from a helicopter. Yeah, you can see the roof just fine, but the critical stuff, deep inside, totally hidden. That's the challenge in today's fabs. Okay, so to solve a problem you can't see, you need a totally new way of seeing. And that's where fringe projection deflectometry comes in. It's this really powerful optical technique that doesn't even try to look through the skyscraper. Instead, it looks for these tiny, subtle clues on the surface that tell you exactly what's going on deep inside. The idea here is actually pretty genius. Deflectometry projects this super precise pattern of light onto the wafer surface, which is like a perfect mirror. Now, a buried defect, even if it's layers deep, creates these minute stress changes that cause a nanometer-scale warp on the top surface. It's tiny, but that little variation distorts the reflection of the light, creating a fingerprint that reveals the location of the unseen problem below. So, how does it actually work? Well, it's pretty straightforward. First, you project a light pattern that you already know onto the wafer. Second, a camera grabs a picture of the distorted reflection. Third, some really powerful algorithms calculate the exact changes in the surface based on those distortions. And finally, boom. This data map points you right to the hidden defects. But here's the twist, and you knew there was going to be a twist, right? In solving the visibility problem, we've actually created a new one, a data problem. These advanced metrology tools are so powerful that they generate a literal tsunami of information for every single wafer. And this quote, it just hits the nail on the head. We're talking about these incredibly high-resolution maps with millions of data points per wafer, generating terabytes of information. So the bottleneck isn't the hardware's ability to see anymore. It's the engineer's ability to analyze this massive flood of data quickly. I mean, having the data is one thing, but you have to turn it into a decision, fast. And this is where AI becomes absolutely indispensable. It's the ultimate co-pilot for the modern engineer. AI and machine learning, they're the only tools that can sift through that data tsunami, find the real signals in all that noise, and turn that overload into clear, actionable insight.
And this has a huge impact all across the fab. AI automates the grunt work, like classifying defects, and it enables things like predictive maintenance to stop tool failures before they even happen. Now, for you lithography engineers out there, think about real-time process control, dynamically adjusting exposure or correcting for overlay drift on the fly to make sure every single layer is perfect. It's just about making every step of the process smarter.
I mean, just look at the speed. What might take a highly trained engineer half an hour to classify manually, an AI model does in real time, instantly. This isn't just a small tweak. It's a complete game changer in how fast you can react to problems. Or let's talk about the equipment itself. Unplanned downtime is a killer for any fab. By analyzing all that sensor data, AI can predict when a tool is about to fail and schedule maintenance before it breaks. The result? A 10 to 20% drop in downtime. That's a huge boost to your OEE. And here it is, the bottom line, yield. By bringing in AI-driven process control, fabs are looking at a potential yield recovery of 3 to 7%. Now, for a big manufacturer, a single percentage point of yield can be worth $50 million a year. So, yeah, This is the kind of financial impact we're talking about when you turn data into real intelligence. Okay, so the case for AI is pretty much a slam dunk. But that leads to the next big question for any fab manager or engineer out there. Do you try to build these super complex AI systems yourself, or do you partner with an expert who's already figured it all out? Building it in-house, it sounds good on paper, but the data tells a really sobering story. More than 80% of corporate AI projects never even make it out of the lab and into actual production. The complexity, finding the right people, the data you need, it's almost always way harder than you think. And when you really break it down, the partnership route has some clear wins. A specialized partner can give you a lower total cost of ownership because the R&D is shared. They give you turnkey solutions that you can deploy in months, not years. And, this is a big one, they have access to a massive global data set from thousands of tools, something a single fab could never replicate, which means you get much more robust and accurate AI models. So really, the partnership model is all about cutting your risk and getting to the value faster. You get solutions that are already validated, built by people with deep expertise, trained on global data, all wrapped up in a secure framework with support for the long haul. Which leaves us with one final thought. The tech to see the invisible? It's here. The AI to make sense of it all? It's ready. So the next major leap forward for your fab's yield and efficiency? It might not be in a new piece of hardware. It might just be hidden in plain sight, sitting right there in the data you're already collecting every single day. The only question is, how are you going to unlock it?